All right, today we are starting our unit all with angle pairs. So everything in our unit has to do with angles. So we're going to start talking about today about different types of lines which create different types of angle pairs. So at the top here is a bunch of definitions. So definition of intersecting lines are two lines that cross. Intersect means to cross. And they're also in the same plane. If they're on different planes, they're never going to intersect. Perpendicular lines are two lines that meet at a right angle, and they are also in the same plane. Again, if they're not in the same plane, they'll never intersect, and they would have to cross to be considered perpendicular. Parallel lines are two lines that will never cross, but are still in the same plane. So two lines really at the same angle, so they'll never intersect. Skewed lines are two lines that don't cross, but they're also not in the same plane. So lines that are in different planes will never cross, but we call them skewed lines if they're in different planes. Think of each segment in the diagram as part of a line. Which lines appear to fit the description? Parallel to line segment AB and contains D. So that have to be in the same plane. So we're talking about this top part of our cube here. So we would say line segment DC. That's the only one that would be parallel to AB, never cross in the same plane that contains D. Perpendicular to AB that contains D, again, we're going to be talking about this plane on the top of our cube here, and it looks like AD would be the one that intersects, that includes D. And of course, you could always name these by flipping your letters as well. Skewed to AB and contains D. So that means it has to be in a different plane. So instead of DC, we could do DH or even DG. I'm going to go ahead and put DH, DG, and DE. All of those are on different planes, so they'd be considered skewed and contain D. Name the planes that contain D and appear to be parallel to plane ABE. So ABE is our plane kind of in the back left here. ABE and F, it looks like. So a plane that would be parallel would be straight across this closer far right plane. And that would be DHGC. So we'll say plane, we only have to have three letters. So we'll say plane DHG. And then there are other planes that contain D, but they would not be parallel. So like ABCD here is a plane that contains D, but it's not parallel to ABE. So I believe that's the only one. All right, adjacent angles we did cover in our GeoBasics packet. That means that they are neighbors. So some examples here would be 1 and 2. They share this ray in between. And actually we need to add that they would have a common vertex. So 1 and 2 is an example, 2 and 3 is an example, 3, 4, 1 and 4, anything like that. Linear pair, so we need to add an R here actually. Linear pair are two angles that add to 180. So again, I could do 1 and 2, but they don't have to be neighbors. So another example I could do is, well, I guess they all end up being neighbors in this example. I could do 1 and 4 as well. But 1 and 3 would not be linear. 2 and 4 would not be linear because they're congruent instead. So vertical angles are opposite to intersecting lines. So 2 and 4 would be an example. They're across our two intersecting lines, and 1 and 3 would be another. And these are congruent. They have the same measure. Supplementary means that they add to 180. Congruent means that they have the same measure. All right, next page. Transversal. Definition of transversal is a line that intersects two or more other lines. So there is a picture example here on the right for you. Again, they are going to be coplanar. Lines can't intersect if they're not in the same plane. Angles formed when a transversal intersects two lines. So the first one is alternate interior. So alternate means opposite. Interior means on the inside. So on the inside of my parallel lines, 1 and 2 would be considered alternate interior, and 3 and 4 would be considered alternate interior. Okay? Same side interior. So again, that would mean on the inside of my parallel lines, being on the same side would be pairs like 2 and 3. And I don't want to put the same number of marks. So I'll use the same color, but they're not going to be congruent in this case. They could be congruent in this case of alternate interior, but they're never congruent for same side interior. So I'm going to use different arc amounts to show that. And then same with 4 and 1. So 2 and 3, 4 and 1. Corresponding means they're on the same side of the transversal in the same position. So for example, 2 and 6 are both on the top right of their line. We could do 3 and 8. We could do 1 and 7, and then 5 and 4 as well. Okay, so top right, bottom right, they're in the same position on both lines. Alternate exterior is very similar to alternate interior, but exterior means the outside. So 5 and 8 would be considered alternate exterior. 6 and 7 are considered alternate exterior. And in our next section of notes, we'll talk about which of these would be congruent and which ones would be supplementary, which is the case when your lines are parallel. But for our purposes today, L and M are not parallel, so we can't assume anything is congruent or supplementary just based on our picture. Okay, list all pairs of angles that fit the description. So corresponding, we could say 2 and 6, angle 2 and angle 6, 4 and 8, 1 and 5, and then last one would be 3 and 7. Alternate interior would be 4 and 5, and 3 and 6, alternate exterior would be 1 and 8, and then 2 and 7. Same side interior would be 4 and 6, and 3 and 5. All right, that's all the possible pairs. All right, at this point, you can start working on worksheet 1 in your packet.